Good morning from Singapore. Welcome back to all the champs who are working very hard to achieve their dreams, to achieve their goals. This is the day 5 of the 100 days of hell with Python algo trading. Today will be the last session of the Python data types and we'll be covering tuples, sets and dictionaries. Then from the next session onwards, we'll be learning functions, then class and all the remaining topics. So without a further ado, let's get started. What are the tuples? A tuple in Python is similar to a list. The difference between the two is that we cannot change the elements of a tuple once it is assigned, whereas we can change the elements of a list. In short, a tuple is an immutable list. This is very important. A tuple cannot be changed in any way once it is created. It's same like strings. Strings are also immutable and tuples are also immutable. We cannot make any changes once we have created strings and tuples. Whereas in list, we can make changes, right? So that's the fundamental difference between tuples and lists. Now let's check the characteristics of tuples. These are ordered, same like lists. Lists are also ordered and tuples are also ordered. So we can say that apart from the immutability, all properties of list and tuples are similar. This is unchangeable because these are immutable, so we cannot make any changes. And then it allows duplicate. So same like list, we can also have duplicate items in tuples. Now let's quickly jump to the Python tuples examples. So first of all, same like list, let's create an empty tuple. So how we can do that? Let's say t1 equals to just parenthesis, the bracket. So when you hit shift enter and print this t1, you will get tuple, the empty tuple, right? And how you can verify that? You can just go and type id here and you can see that the class is tuple, correct? Then let's create a tuple with a single item. So similarly, what we can do, we can write t2 and let's write tuples, correct? And when you hit print t2, you can see that we have a tuples. But how do you know that this is tuples only? It could be a string also, right? And in fact, it is a string. How? Let's check the type of this. And you can see that we have a class str. So how do we create a tuples with a single item? For that, what we can do, instead of this, you can just add a comma here. And when you print, you can see that we have a tuple. So to resolve that confusion, the Python has added a comma here. So we can differentiate between a single string or any single integer here. So when we add a comma here, it will become a tuple. For the tuples with more than one item, there is no issue like that. And similarly, for homogeneous tuples, same like a list, what we can do, I'll just copy and paste it here. So the first item is a string. So for homogeneous tuples, we have to have all the items as single data type, right? So this also I can have like any string. We can say like, let's say BTC, then ETH. And when you print this out, you can see that we have the tuples BTC ETH, right? This is homogeneous. And similarly for heterogeneous, what you can do, you can change this value to any other. It can be an integer, then string. Then you can change this to a float. So a float could be 1.5, then Boolean value, correct? It will become a heterogeneous tuples. So when you print it out, T2, it will be printed out as a heterogeneous tuples, correct? And again, using type conversion, this exactly same like we did in list. So for example, we have a string, let's say BTC, correct? And when we check the type of this, it will be the string, right? But what you can do, you can just convert the type of this. So you have give here tuple, okay? And when you check the type, you can see that it has converted to tuples, right? So now as you can see that almost all the properties are same except the immutability, because tuples are immutable, so we cannot make any right changes. So like adding an item, editing an item, we cannot do that. So now let's quickly check out how to access items from a tuple. So let's say we have this tuple. Let me copy and paste this here. Okay. Same like list. What we can do, we can access like T2 and 0. The 1 will be printed out. And if I go T2 with the index 2, the float will be printed out. And with the 3, we will be having a Boolean value. Same for slicing. Slicing also works exactly same like strings and list and then in tuples. So how you can do that? let's say you want to print only these values, BTC and 1.5. So we know that this is at the index position 1 and 1.5 is at the index position 2. So for that, we have to write 1, the starting position, then 3, right? Plus 1. And when we hit shift enter, we get both the values, correct? And same you can achieve with the negative indexing. So this is -1, this is -2, and BTC is -3. So you have to write -3, then up to -2, but you have to write +1. So it will become -1. And when you enter, you get the same value, right? Next is editing items. So let's try some editing here. So we'll just copy and paste the same tuple here. So let's say I want to change this value BTC to ETH. Okay, so what I can do, I'll just write T2 and the index position of BTC, which is at 1, and I will try to change this to ETH. So when I write ETH here and shift enter, it gives me tuple object doesn't support item assignment. Of course, because these are immutable and we cannot make any changes. So that's the difference, right? That's the major difference between list and tuples. And same goes for adding items. As these are immutable, we cannot do. So let's try to do that. For example, if I append here, so append will not work, correct? Also, adding items is not possible in tuple. So there is no function for adding item. Same goes for deleting. So if you try to delete any item here, it will not work. So let's try to delete a single item from a tuple. So what we can do, we'll write delete, then T2 and the index position of that item. So let's say we want to delete the first item. So I'll type here 0, and when I hit shift enter, I get that tuple object doesn't support item deletion. Same, it doesn't support item assignment, and it also doesn't support the item deletion because these are immutable. But we can delete the whole tuple. That's possible. So when I check that, you can see that now it doesn't exist. So when I try to print T2, it will say that the name T2 is not defined because it has been deleted. So that's how the deletion works here. Then we have operations on tuples, same like list. So let's copy and paste the same tuple here. So let's say we have another tuple T3, which has the values like 2, then ETH, and let's say 2.5, and this is false, correct? So when you try to add these two tuples, it will be printed out. So we can say that only the addition and multiplication arithmetic operators works on tuples, same like list, right? If you want, you can also use the multiplication here. So when you multiply T2, you will get the value like this because it will be printed out 2 times. If you want, like, let's say 4 times, then you can do that also, and you will get the same tuple 4 times, correct? So let me change it. Then we have the membership operation. So what we can do here, let's say I want to check whether BTC is existing on T2. So let's say here I want to check whether BTC string exists on T2 tuple or not. So what I can do, I'll write BTC in T2, and when I hit shift enter, it gives me true because it does exist. But if I change it to T3, but in T3 it doesn't exist. Similarly, we can use the not in. So when I check not in BTC, not in T3, so it will give me true because it doesn't exist in T3. It exists in T2. So here it will give me false value. So it is false. So it's very same. It's very simple and similar like the list. And for iteration also, this works same. Let's say we want to print all these values, T2 and T3. So we can apply a for loop here. So for I in T2, print I, and again for j in T3, print j. When you hit shift enter, you get all the values. So we can say iteration also works exactly same like list. So now we have the same functions: len, sum, minimum, maximum, sorted. So let's quickly perform that. So let's say I apply the len function here on T2. So len T2, it will give me the length of this tuple. If I apply sum on this, what we will get? Pause the video and give me the answer. we'll get an error because here we have multiple data types and some function cannot work on that. We need to have a homogeneous tuples for that. So let's say we have another tuple which consists of 1, 2, 3, 4, and if I apply sum on T3, it will give me 10, right? The sum of these values. Again, we can apply minimum also, but only on the homogeneous tuple. So here, when you apply, you will get the minimum value. Similarly, max sorted also, you will get the values in ascending order. And if you want the value in descending order, you can just write reverse equals to true and you will get in reverse order 4, 3, 2, 1. So now we have a count function here. So count also print out the number of times any item existing in that tuple. So let's say we will copy and paste this 3 times. So again, and when I check that t2 dot count, and let's say we check for the BTC string, correct? So when I hit shift enter, I get 3 times because BTC, 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 it exists 3 times. Similarly for the index, if I apply here, so it will give me the index position of BTC, the first occurrence, right? So we will get the first 0 and 1. So let's say if I add another value here, 2, 3. So now the index position of BTC is 0, 1, 2, 3, right? So when I hit shift enter, I get the 3. So that's how it works. It's very simple. It's very easy. If you have understood strings and lists, then you should be having no issue here, right? So now let's check the difference between list and tuples. The first, of course, syntax. So the syntax of list is we write with the square bracket, but for the tuples, we have to write the parenthesis, the round bracket. So we have to write like this. Then the second difference is mutability, correct? Lists are mutable. We can make changes in that. We can add, we can edit, we can delete the list, but in tuples, we cannot make any changes. So it becomes immutable. Then we have the speed. So for the speed, what happens? You can think that all the immutable data types are faster and mutables are a little bit slower than the immutable, correct? So we can say strings, tuples are faster than list, correct? Then we have the memory. Of course, same like speed, tuples occupy less memory than the list. Next, we have built-in functionalities. So almost all functionalities are same except the writing operation. So in tuple, we cannot perform the writing operation because we cannot make any changes. We cannot edit, we cannot delete. So you can say except all the writing operations, we have similar functionalities on both the list and tuple. Then the next is error prone. Yeah. So as we can clearly understand that lists are more error prone because as we understood in the last session, list, we took an example that how lists are error prone because lists can be changed, lists can be edited, and lists can be deleted. So lists are more error prone than tuples because tuples cannot be changed. These are immutable. So we cannot make any changes. So in short, we can say lists are more error prone than usability. So when it comes to usability, so in usability, you can use tuples where you don't want to change the data. For example, we have a strategy and we want to set the parameters to strategy parameters. So here I want a short window of 50 and the long window of 100 for SMA and EMA. Correct. So these should be same. I don't want to change this throughout the program. So in that case, you can use tuples. It's that simple. So now we will take an example where we will measure the time taken for various operations like creation, access, and iteration. Then we will compare the memory size of list and tuples. So first we will import the time and sys library, and then we will quickly create the number of elements to use in list and tuples. So here we will take the number of elements as 1 million, and here we will generate the sample data. So the range will be from 0 to 1 million and it will create a list, and that list is being stored in the data variable. Now we start with the major memory sizes. So here I am creating 2 variables. First is data list and second is data tuple, right? Now when I check this get size of function will check the size of that particular variable. It will print out the size, correct? So here it will be printed out. Then we check the time measurement. So here what is happening? Here we check the start time of that operation, and here we are performing the operation, and then we are checking the end time of that operation. Here we will print out the end time minus start time. So it will give us the seconds, how much time it took to perform that operation. Similarly, it is for list. So that was for the creation. and this part is for the access. So how much time it takes to access the elements from list or from a tuple. So it will be measured out and then we will print it out. And then next we have the iteration. So how much time a list take for the iteration, and similarly for the tuples, correct? So, and then we have the time measurement for append, which is only for list. And again for the extend, that is also for only list, because tuples doesn't support any write operation, right? So we cannot append or extend the tuples. So when we hit shift enter, we get the value. So now here you can see that the size of the list is slightly bigger than the size of the tuple, correct? Again, the list creation time is slightly more than the tuple creation time. Similarly, for the access time, tuples are slightly faster. So when we have a large amount of data, it makes a huge difference. So while dealing with HFTs, high frequency trading, it makes a lot of difference. Then you can see the list iteration time and the tuple iteration time. Tuples are slightly faster. And last we have the list append and extend time. So here we cannot compare because tuples doesn't support that. So after this session, you can go through this document and you can read more on the tuples and list. Now we take this example where we will try to append some value in the list, and then again we will try to append some value in the tuple. So here you can see that we have a list which has the items 1, 2, 3, then b equals to a, and when I append 4 into that list, we can see that we have change in both the variables a and b. Similarly, when we check for tuples, a equals to a tuple which has 3 values 1, 2, 3, and b equals to a. So now b and a points to 1, 2, 3, and when I add another tuple here 4 and shift enter, so here we can see that only a has been changed. There is no difference in the b. So that's how we can compare the list and tuples. Okay. So now we have a question, why use tuples? So in algo trading, you can say that when we want the immutable data structures, we can use tuples. When we want efficient memory storage, we can use tuples, as we have seen in the above example. When we want hashable keys for dictionaries, we can use tuples. We can use tuples at fixed and unmodifiable data sets. And again, improved performance for read-only operations, because write operations we cannot perform on tuples. So that's where you can use tuples in algo trading. So now the next topic is special syntax. So here we have tuple unpacking. So let's say we have a tuple which has date, open price and high price. So we want that these all should be assigned to date, open price and high. So in this way, in this syntax, you can write and the values will be assigned to each one of them. The date will be assigned to this one, the open price will be 100 and the high will be 110. You can even check here, you can print the values, print. Let's take all these together and you can see it says too many values to unpack. Okay, yeah. So, but here we have to see this one, correct? It has printed. The error is for this one. So let me comment it out for now. So now you can check that we have the date here, the opening price and the high price, correct? Now, for example, what you did, you have 3 items in the tuple, but you assign only 2 variables here, then it will throw the error. So let me comment out this, and when I hit shift enter, you can see that we have this error, value error, too many values to unpack, expected 2. So here what you can do, you can add another variable here, or you have to remove one value from here. So let's say we remove this 110. Now we have only the date and the open price. So now if you hit shift enter and print out these values, print, and you have the date and the opening price, correct? Now let me comment it also. So this example is for the use case of tuple unpacking in the algo trading. So let's say you have the trade data, which is a list of tuples. Okay, this is a list, and in that we have the items as tuples, right? So here you can iterate over trade data, and you can see that we have assigned date, which will be the first item of tuple, then the open price, then high, the low, close and volume. And when we run that, we will get all the values. So that's how you can use the tuple unpacking. Next is this. Similarly, we have a tuple which has 4 items. Let's say here we just have 2 variables, a and b, and rest we want to store in the other variable. So far we don't know what is the name of that variable. So this way we can assign ab equals to 1, 2, and the rest items will go to the others. So when you print it out, you can see that we have 1, 2 and in the others it will be 3 4. You can have as many as you want, and when you hit shift enter, the other will have all these values. Okay, similarly you can check this also. So when you print it out, this is a use case of tuple unpacking. Let's say I print this, so let me print these in other for better understanding. Print open price, and then I will print the others. Let me comment out these. So you can see that in date we have this one, and open price which is 106, and the rest values is inside the others variable. So that's how you can use this. Now we have the last zipping tuples. So we have already understood the zip function in list, that is exactly the same. So here we have two tuples, one is trade log and another is trade log 1. So we will zip it first, and then okay, so you know that when we apply the zip function we get a zip object. So when you hit shift enter, you will get a zip object, and then you have to pass it to tuple, right? So when you hit shift enter, you will get the value. If you want, you can also pass it to a list, so you will get a list. So it's just the difference of name and syntax, otherwise everything is same. So with that we have covered tuples. It is also very important, and you have to go through all the multiple choice questions on tuples and task questions and the mini project. You cannot afford to miss those things. If you miss, then definitely you will be having problems while doing the trading, and that time you cannot afford to come back to the topic. You can reading again, it will be much difficult for you. So it's better to understand the topics right now, and later you will be having a lot of convenience.